We will create a basic waypoint system, create a simple entity patrolling those waypoints using Unity Snap Mesh, creating a custom scene view where we can drag around the waypoints, and creating a custom inspector for our waypoints. And this is a preview of the end result. For the demo scene, I have created a floor with 2 ramps and a runway, and I baked those using Unity Snap Mesh system. And for the player, I have created an empty game object, added a Nav Mesh agent component, and as child objects I have created a capsule body and a cube nose. We will later add a player controller to this game object using our waypoint system. Let's start by creating our waypoint system and add a folder called waypoints and a folder called scripts. And let's add a new C# script and call it waypoints and open that up. I usually start by adding my class to a namespace, FG for future games. And what my waypoint system will consist of is basically just an array of positions. So let's create a public vector3 array called points. Let's add our player controller. So let's open up the Solution Explorer and switch to folder view. And in our demo scripts folder, let's add a new item, and let's find a Visual C# class. Let's call it player controller. Our player controller class needs to inherit from money behavior, so we can add it to a game object. Let's also add using Unity engine.ai to access our Nav Mesh agent, and assertions to help us with error handling. We're going to add 2 class attributes to the player controller. The first is selection base. This means that when we click a child object, the game object that will be selected is the game object with the player controller component on it. The other one is require component, where we add a type of Nav Mesh agent. This means that this game object must have a Nav Mesh agent on it. So if we add the player controller component to a game object that doesn't have the Nav Mesh agent component on it, it will be added by Unity. Okay, we are going to create some variables, some member variables, and we need one instance of a waypoint system. Let's call it waypoints. And make it public so we can set it in the editor. We are going to need to keep track of the current waypoint index, what position we are currently travel towards. And we're also going to need our Nav Mesh agent. And in our awake method, let's get the agent And let's make sure we get one, even though we have the required component on it. So we're going to use assertions. So type in assert, and in this case we're going to make sure that agent isn't null. So we have is not null, and you send in the object, which is agent, and a message to print out to the console if this agent is null. So if agent is null, we will throw an error. Let's also make sure that we have a waypoint set. And that we have a stopping distance on the nav agent greater than 0. Otherwise we might get some funky behavior. So let's make sure that something is true and that the agent stopping distance is greater than 0. In start, we are going to get our character to move to the closest waypoint. So we need a method to calculate what the closest waypoint is. So over in our waypoint class, let's create a new method. It's going to be public and return the index of the waypoint we are closest to. So let's call it get closest waypoint. It requires a position. This is known as the nearest neighbor search problem, and the easiest way of solving it is by implementing the linear search algorithm, where you calculate the distance from the query position to every other position, keeping track of the best so far. The car represents our position, and the targets are the different waypoints in our array. We then traverse the entire array, checking if the current distance is closer than the previous one. And if it is so, we change it to be the best so far. In pseudocode, it might look something like this. So take your time and try and solve this before I show you how to. Okay, we know we want to keep track of the closest distance, which is a float. And let's set it to a really high value. And we also need to keep track of the closest index, which is an int. And then we need to go through every point in our points array. Here we need to calculate the distance between our position and this very point. And if this distance is closer than the previous distance, we save it down. and then we return the index. Back to our player controller, we can now set the current waypoint index to the closest one in start. Let's also make sure that we have a valid index. And then we set the destination so the entity starts walking. And instead of going waypoints.points and waypoint index, let's make it so we can just type in this and save us some typing. So in waypoints class, we're going to add a property that returns a vector 3. Let's add a get. And a set. And now this is a valid way of typing. In update, we are going to make sure that the entity cycles through the waypoints. So if the agent is close enough, we are going to set the new waypoint index we're going to move towards. And since we don't want to go waypoints.points.length, we want to do it like this instead. So let's add that property to our waypoint class. And then we need to make sure that we set the destination of our new target position. Back over in Unity, let's add the player controller to our character, and we also need the waypoints. So let's create an empty object let's call it waypoints. And add the waypoint component to it. And just to make sure this works, let's add a few. And now the character should be able to walk between those points. Nope. Let's see. We need to make sure the player has the reference to the waypoints. Yeah, it works. The next step is to create an editor for our waypoint system. And all editor script needs to be in a folder called editor. So let's create one and add a C# script called waypoints editor and open that up. Let's begin by drawing the scene view. So we're going to need some variables for that. We are going to draw a dotted line between all the waypoints, and we want a size modifier. We also need a reference to our waypoint. And before I begin, of course, this being an editor, we are going to need Unity editor. And we are going to inherit from Unity editor.editor. And I'm using the namespace here because I'm going to place this in my own namespace called fg.editor. So without using Unity editor here, I would have a name clash with my editor namespace. We want our tool to look like the Unity editor does regularly, so we need to get the skin, the GUI skin. So on enable, let's grab that. We also want to hide the position handle on the game object that we have selected itself. So we only have to deal with the position handles of each point. We do that by setting tools hidden to true. And we need to set that back on disable. We must let Unity know that this editor is for our waypoints class, and we do that by giving the class a custom editor attribute where we enter the type of waypoints. So now every time we select a waypoint object, this will be the editor for it. So it might have a custom inspector or a custom scene view depending on what method we override in our editor class. To get the reference to the waypoints, we have a variable in our base class called target. So we do a waypoints equals target as waypoint, so we cast it to the type we want. Of course, making sure that we have the right type. To have a custom scene view of our waypoints, we need to implement a method called onSceneGUI. And here we're going to add position handles to all the waypoints. So we're going to have to loop them through. And we're going to type out the index of each waypoint next to the handle, next to the position handle. So we use the handles class, and let's create a label. And we begin by entering what position we want the text to be. The next part is the text, so the index to string, and this next is the style. So we can use our scene GUI, and I'm going to use the text field style. So that will be a transparent gray box with the text inside. When we modify the position of a waypoint, we want to be able to let the user undo and redo changes. And to do that, we call editor GUI and begin change check. So we let Unity know that we are potentially modifying a value. Then we create the handle itself, and we want to save down the new position. So we use handles, position handle, and we enter the current position, and we are not going to rotate our waypoints, so we just do a quaternion identity. Then we ask if we actually did change something, if a value in our waypoint component changed. So we ask the editor GUI end change check. So this will be called if we changed anything. And in this, if that's the case, we need to create the undo record object and saying that this object changed, and we need to give it a name, and that's the name that will be in the menu when it says undo something something. And then we need to set a new position to that waypoint. The next part is drawing the dotted lines between each waypoint. So let's create a new method called draw connected lines, and let's create an implementation. Alt enter to generate the method, or if you're using Visual Assist, Alt Shift Q and create method. In here we're going to let Unity draw the dotted line for us, so we can use the handles draw dotted lines. So we're going to use this one where we enter the points, we enter the indices, and we enter the screen space size. So let's begin by adding the points. We're going to create a variable called segment indices, and we do have the space size for the dots already in dash size. So the segment size variable is an int array, and that's something we need to create. So let's create a method called create segments. A line segment are the start index and end index of a line. So for instance, the first line starts at index 0 and ends at index 1. And to create this array of segments, it helps me to type it out. So for instance, the first line consists of 2 parts. So this is the start of the line and this is the end of the line. And these two together, this pair, makes an entire line. So the first start of a line is index 0. And that one ends at index 1 of these points. Meaning that the second line starts at index 1 and ends at index 2. And the third line, this is the start and this is the end of that third line, starts at index 2 and ends at index 3. And because we're going to loop it, so for instance, if we add a last line, that one ends at, starts at index 3. That's the last point in here, and therefore ends at index 0, being our first point in our points array. So to create this, we begin by making sure that we have enough points. So if waypoint's length is less than 2, let's just return. We can't build a line if we don't have at least 2 points. Otherwise, create a new int array, and the size of course needs to be twice that of the number of points we have, because we're working in pairs. And we're going to need to keep track of the index, the previous index that is, and then loop through the segment indices. So let's call this one start, and let's run as long as we have a segment -2, and we're going to jump over every second one. So the segment indices start equals index, then we increase index by 1. This will then be the end of that line, and you start +1 equals index. And then we enter the last line from the last point to the first waypoint. We need to do that outside the loop. We need to make sure that the create segments method is called, and we do that on enable. And we also need to make sure that if we undo or redo, we call the create segment. And to do that, we go to our on-scene GUI. and we ask if the current event that is taking place in the editor, if that type is a event type dot validate command, and if that command name is undo redo performed. If that's true, we create the segments again. So back into the Unity editor, we now see that we have position handles for all our elements, but not for the Waypoint's game object itself. We can still move it about, we just don't see the position handle for it. And for all the points, we can start dragging them out. We see the index and the dotted line between those, and we can undo and redo. The next part is when we hold down Control, we want to be able to create a point between 2 points. So we will display a sphere along a line, and when we click it, we will create a new waypoint between those points on that line. For that, we need to create the lines. Basically, we already do have the lines, but since we're looping it, we need to create a copy of the points we have and add that last line between the endpoint and start point. So let's create a private vector 3 array called lines, and we are going to create a method called createLines, and we need to call it from onEnable. Also, when we undo or redo, and then we implement the method over here. So it's a private void createLines. And basically what we do is we create a new vector 3 array, which has the same size, or almost the same size, as waypoints.length plus 1. Let's see, something is off here. I'm outside the class. Like that, and then we copy the values from the points variable in waypoints into the lines, and then we add that last part. So then we need to draw the point on the lines. So let's create a method called draw closest point on lines. And let's make sure we call it from our onScene GUI method. And I notice an error here in our createLines. This of course needs to be the vector at index 0. And now we can implement the draw closest point on lines method. So let's start by getting the current event. And if that event means if we're pressing down Control, and we're going to display the sphere on a line, on the closest point on a line. And we can use a ready-made method for that, where we get the point position, and we call handle utility closest point to polyline, and we give it our lines. So this will calculate a position on one of the lines that we are closest to. Then we need to draw the sphere, and we want that sphere to be green, so let's go up here to our fields and create a private color. Let's call it point line color. Let's make it green. Then we go back again. So let's save out the previous color. And then we tell handles that the current color should be the same as our point on line color. And we must reset it later, so let's do it. And in between here we draw the actual sphere. And for that we can do handles draw solid disk. We give it the position, the normal, and the radius. So the position, it's point position. Let's rotate it towards the camera. And this is of course the scene view camera, the scene camera. And for the radius, we're going to use handle utility get handle size. That way we will scale the size depending on how far we are away from this position. So point position, and let's multiply that by 0.1. And we need to tell the scene view to repaint. Then we need to check if we press the left mouse button, we're going to add a point. For that we need to set the current hot control to 0. This is the ID to the current control. Doing this allows us not to, when we press, we don't select any other object in the scene. So we basically remove that function. And then we need to get the index of the closest line, so we know which line we are, or which 2 points we're creating a new point in between. And for that we're going to have to create a new method. Let's call it get index of closest line and give it our position, so that's point position. And let's implement it. Alt Enter, or Shift Alt Q if you have Visual Assist. So in here, this is basically the same as our our waypoints when we calculated the get closest waypoint. So we need to keep track of distance. And the index. And then loop through our lines. Then we can use the distance point line method to calculate the distance between our position and a line. To not get a index out of bounds exception, we need to do the length of the lines -1, of course. And if current distance is less than previously best distance, we save the distance and the index. And then return index +1, because we want to add the point after the point where we clicked. So back here we get the index of the closest line, and then we need to add an element to an array. And since we can't really do that because an array is fixed sized, but we can use reflection, and Unity allows us to do this with their help. So we need to create a serialized property. Let's call it points property. This will be the array variable in Waypoint, so this points. And to get that, we go to onEnable and points property, and then we search for that property. So just as we have a target, because we inherit from editor, we also have a serialized object. And we do find property and enter the name of it, which is points. Yeah. Then we can go back down. And points property, and this allows us to insert an array element at index, and the index is of course this one. And then we need to serialized object, yeah, and apply the modifications. So this saves our changes to the array. And then we need to set the position of the new waypoint. So waypoints, we have our index equals point position. And then of course we need to recreate the segments and create the new lines. Then we need to tell Unity that we used this event, so no one else can also react to it. And of course I made a small mistake. So down here the index should of course not be 0 but rather I. The last part is to create the custom inspector, and for that we need to override the onInspector GUI method. And if we want to draw the regular inspector, we can do so by calling our parent class base onInspector GUI, but we're not. If we don't have any points or any waypoints, if length is 0, we're going to display a big plus button which we can press to add a waypoint. We do so by doing a GUI layout button, and if this returns true, that button was pressed. We want to display a plus icon, and we can get those. We can get a lot of different icons from the Unity editor by using editor GUI utility icon content, and then we add the string name, which in this case is the toolbar plus. And if you search for this online, you can see a list of icons you can get. We want it to have the same width as the inspector window, so we're going to ask it to expand. And if we press this button, we need to use our points property and insert element at index 0, adding our first waypoint. And then we need to apply the changes. And then the position will be where we're currently located at in the scene. So we ask our scene view, the last active scene view, for its camera, and we take the position and add its forward. So scene view, last active camera, transform. Of course we could catch this because this is getting tedious and repetitive. Forward, and let's multiply that by a certain number, 1.5. That's the distance from the camera basically. And by doing so, we need to recreate the segments and the lines. If we already have waypoints, we need to loop through them. And we are going to list the index of the waypoint, that's the position in the array, the vector field, and a plus button to add one below it, or a minus button to delete that waypoint. And we want those to be on the same line. So let's create a editor GUI layout begin horizontal, so they will align. And for every begin, we need a editor GUI layout and horizontal. And in between here, we type out the properties, not properties, but the widgets we want. The index will actually be a button, and when we click it, we will focus on that point in the scene view. So let's create a new button. And the text will just be the index. And we are going to make it look like the regular inspector. So we need a inspector skin. So just like we did with the scene skin, let's create a inspector skin. And in here, on enable, we do inspector skin and ask for that. Then we go back to our on inspector GUI and add the inspector skin button look to it. We don't want it to expand on the width, so let's do a GUI layout expand width set to false. And if we click it, do a scene view last active scene and ask it to look at that position. And then we want the vector field displaying the X, Y, and Z component. And since we can modify those, we need to do a begin change check so we can undo and redo as well. So let's do editor GUI begin change check, and then we take the value from a editor GUI layout vector 3 field. The label for that vector 3 field should be empty, since we are displaying the index of it instead. The value we get from the index, and this one should expand. And then if this was modified, we set the new value, and we do a undo record object on waypoints and call it moved waypoint. Then we need to repaint the scene views. So scene view, let's repaint all of them. And for the scene to be set as unsaved, so we know that we need to save it, we can do a editor utility set 30 and waypoints. Then we need the plus button next to the vector field. So if we want to add a new waypoint below this one, so we do a GUI layout button and do a editor GUI layout, utility icon content again, and the name of this one is D2 toolbar plus as well, and this should not expand. And if we click it, we need to insert an element at y+1, so it will add a waypoint below this one. And we apply the changes. And the position of this one will be in between this one and the next one. The position of the new waypoint should be between 2 points if we have them. So let's create a vector midpoint, and if we have more than 2 waypoints, and the next waypoint is the last waypoint, we create a direction variable between the next to last and the last waypoint. And let's normalize them. So this way the new waypoint will be in the center between those 2 last points. Otherwise, if the next waypoint is the last one, the midpoint will be the last one, and let's just move it to the right side. Otherwise, midpoint will be in between those 2 lines. Then of course we need to create the segments again and the lines. Before implementing the absolutely last part, let's correct this small mistake here where I forgot the parentheses. And then we need to implement the delete button of a waypoint. So let's create a grid layout button, and the icon is the toolbar minus, and this button should not expand. So when we click it, we should delete an element at index I. Save the changes and recreate the segments and the lines. And then because we removed one, we need to do I-1. And now we can also create new points in the inspector and delete them and focus in on the different waypoints.